Chapter 6, Unit 3. Probabilities and proportions for scores from a normal distribution. So many times you're given specific scores, which we call X values, and asked to find probabilities. The key to take away from this chapter is that you must convert to z-scores first before finding probabilities. So here's an example. It is known that IQ scores form a normal distribution with a mean of 100 and standard deviation of 15. Given this information, what is the probability of randomly selecting an individual with an IQ score of less than 120? This can also be written as what proportion of all individuals in the population have IQ scores of less than 120? Either question is answered. So step 1, you're going to draw a picture and you're going to draw a line at x equals 120. And the picture is always going to be of the normal curve. Step 2, you're going to shade to the left of that line because the problem asks for any scores less than x equals 120. And then you're going to label it as a body or a tail. So in this case, the shaded part is the body because it includes the mean, or the z-score of 0. It's the larger portion, so it would be a body. Your next step is to find the z-score for that score of 120. So use your equation, find a z-score, and you should find 1.33. Again, you can label it with your graph. Look up 1.33 in the tables for the body, and you're going to find that the probability that a score is less than 120 is equal to the probability that a z-score is less than 1.33, which equals 0.9082. Okay, here's another example. The Highway Department conducted a study measuring driving speeds on a local section of interstate highway. They found an average speed of 58 miles per hour with a standard deviation of 10. The distribution was approximately normal. Given this information, what proportion of cars are traveling between 55 and 65 miles per hour? In statistical terms, you would say P parentheses 55 less than X less than 65. So first step, you know the mean and standard deviation, so you can make a graph of the normal curve and the table using your information. Then you're going to draw lines at the two scores they gave you, 55 and 65. And this problem asks for a probability between two scores, and the mean is actually in the middle of these two scores somewhere. So you're going to separate this into two separate problems by drawing a line straight down the middle of the distribution where z-score is equal to 0, right at the mean. Okay, and then you have problem 1 on the left, problem 2 on the right. So next off, we need to determine the z-score for your x of 55 and a z-score for x of 65, so you can use the equations to do so. You'll find the z-score for 55 is negative 0.33, z-score for 65 is positive 0.70, and that agrees with our table that we made. Finally, you're going to use column D, and you're going to find the probability between the mean where z is equal to negative 0.33 in the mean, and you're going to get 0.1179 on your table. And then you're going to find the probability between the z-score of 0.70 and the mean, and you should find 0.2580 on your table. Again, pause the video, make sure you can find these numbers on the table. Finally, to find the answer to the question of what proportion of cars are traveling between 55 and 65 miles per hour, you would add up the probability you got for part 1 to the probability you got for part 2, and the sum would be 0.3759, which would be the total probability for the entire area. Here's another example using the same scenario, only this time it wants to know what proportion of cars are traveling between 65 and 75 miles per hour. So again, you make your table and graph, you draw your lines. However, this time the mean is not included between those two lines. So we need to think of a different way to solve this problem. We can't use column D, or we're not going to. So what we're going to do here is first we're going to find the probability of problem 1, which I've labeled the line on the left. I'm going to find the probability from problem 1 all the way that entire tail. And then I'm going to find the probability of where line 2 is, part 2, all the way over to the tail. And I'm going to subtract it off. So the whole improbability from 1 all the way to the right minus the probability of where line 2 is to the right will give us the distance in between, the probability between the two scores. So the way we do this is, first off, we always convert to z-scores. So we're going to find a z-score for 65 and get z equals 0.70, and then find a z-score for x equals 75, and we're going to get z equals 1.7. Then we're going to use column C because that's the one with the tail, since both of these are tails. And we're going to find that the probability of x greater than 65 is equal to the probability of z greater than 0.7, and that's going to equal 0.2420 from the table. We repeat the same procedure, and we get the probability of x greater than 75 is equal to 0.0466. Finally, to find the area in between, we are going to subtract the probabilities, and we get 0.1974. Here's another example. For a normal distribution with a mean of 60 and a standard deviation of 12, find the probability that x is greater than 66. So you simply make your graph, make your table, draw a line where x equals 66 would be, shade to the right of that line since it asked for greater than 66. Then you need to determine if it's a body or a tail. In this case, it's a tail on the right because it does not include the mean. So step 4, you find the z-score. You should find that z is equal to 0.50. Finally, because it's a tail, you're going to use column C, and you're going to find that the probability that x is greater than 66 is actually equal to the probability that z is greater than 0.5, which equals 0.3085. Example 2. For a normal distribution with a mean of 60 and a standard deviation of 12, find the probability that the score is between 48 and 72. Step 1. Make a table and a graph. Step 2. Draw lines at x equals 48 and x equals 72. Step 3. The problem asks for a probability between two scores, and these two scores have the mean, or z equals 0, between them, so draw a line down the middle of the distribution. Separate this into two completely separate problems. Problem 1 is on the left, problem 2 is on the right. The next step is you're going to have to determine z-scores for your two x values. You can read them directly off your table if you like. You'll find that a score of 48 gives a z-score of -1, and a score of 72 gives a z-score of 1. If you want to verify your work, you can calculate the z-scores. You'll get the same answers. Finally, you're going to use column D to find the probability between the mean and a z-score. So let's do problem 1 first. Find the mean between if z is equal to -1, and you will get an answer of 0.3413. Remember, when you look on the tables, there are no negative z-scores, so you just look z equals 1 on the table. And you do the same thing for the other side, which is z equals plus 1.00, and again z equals 1 in the mean. The probability on the table is 0.3413. So now you have the probability for both parts, and you simply add them up to find the total probability between 48 and 72. You should get 0.6826. Example 3. The Census Bureau reports that Americans spend an average of 26.1 minutes commuting to work each day. Assuming that the distribution of commuting times is normal, with a standard deviation of 10, how much time do you have to spend commuting each day to be in the highest 10% nationwide? First off, you make a graph only. You can show the 50 percentile or z equals 0 if you like. Next, you draw your line at the highest 10%. Again, you start on the right and you go 10%. You shade the right side of the line since you asked for the highest part, and you determine if it's a body or a tail. In this case, it would be a tail. Then you determine the z-score for 10%. Remember, you have to change the 10% into a p-value, which is p equals 0.1000. So on the table, you're going to find what z-score is closest to p equals 0.1000 in column C. And you're going to find a z-score of plus 1.28. Finally, in order to find x, or how many minutes you need to commute each day, you need to use your x equation, which is the mean plus z times the standard deviation. And we know what the mean is, we know what z is, we just solved it, and we know the standard deviation. So plug those numbers in, and you will find that you need to commute at least 38.9 minutes to be in the top 10% nationwide. So this is the same problem we had a few minutes ago with a mean of 26.1 minutes commuting to work, standard deviation of 10. Only this time the question wants to know what is the range of time spent commuting each day to be in the middle 90% of the distribution. So you make a graph. Remember, when you're given percentage problems, you do not make a table. You draw lines for the middle 90%, and because it's the probabilities between two scores, you draw a line at the mean where z equals 0 between them, right down the middle of the distribution, and you separate it into two separate problems. So part 1 and part 2 would each have 45% of the distribution. So you just take 90% divided by 2 to get that 45%. Next, you determine z-scores using column D to find the proportion between the mean and a z-score. You're going to try to find column D that has the proportion closest to 0.4500, and you're going to find that there's going to be two that are closest. You're going to use the higher value one of 0.4505 in the D column, and then you're going to read across to the left, and you're going to obtain that z-score as 1.65. Label the value on the graph as I did here, and you notice that there are two boundaries, one on the far left, one on the far right. They're both 45%, so one is negative 1.65 and one is positive 1.65. Now, in order to find the x values, or the minutes commuting, which was our original question, we have to use the x equation. Again, we know the mean, we know the z-score and standard deviation. So the first row, I put in a z-score of negative 1.65, and that gave me 9.6 minutes commuting. And then for the second score on the far right of the range, I put in a z-score of positive 1.65, and that gave me 42.6 minutes commuting. So this means that you would need to spend between 9.6 and 42.6 minutes commuting to be in the middle 90% nationwide. Learning check problem 1. Pause the video, see if you can solve the problem. The population of SAT scores forms a normal distribution with a mean of 500 and a standard deviation of 100. What proportion of the population consists of individuals with SAT scores higher than 400? Step 1, draw the picture and the table. Step 2, draw a line where x is equal to 400. Step 3, you're going to shade to the right of that line because the problem is asking you for SAT scores higher than 400. Label as the body or the tail. In this case, to the right of 400, it's going to be a body. It's because it's the larger portion and it includes the z-score of 0. Next, you're going to actually find the z-score. You can just read it off your table. You'll get a z-score of negative 1. If you feel like verifying it, you can use the z equation. You'll still get negative 1. Finally, you're going to use your tables. You're going to look up z equals 1 in the tables. You're going to read across to the body column to find that the probability of x greater than 400 is equal to the probability of z greater than negative 1, which equals 0.8413. Learning check problem 2. Pause the video and see if you can work the problem. A normal distribution has a mean of 100 and a standard deviation of 20. What's the probability of randomly selecting a score greater than 140 from this distribution? So draw the picture, make your table. Draw a line at x equals 140. Shade to the right of that line because the problem asks for a score greater than. This would be a tail, on the right-hand side because it does not include the z-score of 0. Step 4, you're going to find the z-score. From that table, we can read that the score of x equals 140 corresponds to a z-score of 2. You can verify it using the equation. Finally, you're going to look up in your tables 2.00 for the tail to find that the probability of x greater than 140 is equal to the probability of z greater than 2, which is equal to 0.0668. Learning check problem 3. Pause the video, see if you can work the problem. For a normal distribution with a mean of 70 and standard deviation equals 10, what is the minimum score necessary to be in the top 60% of the distribution? Step 1, make a graph, and only a graph, because when you're given percentages, you can't make a table. Draw a line at the top 60%. Remember, you're going to start on the far right because it's at the top, meaning far right, and you're going to move your pencil to the left. You're going to go past the 50% mark and a little bit more because the top 60% is what we're after. You're going to shade the right side of that line since it asks for the highest portion, or the top 60%. And this is going to be a body because it does include the mean, or the very top of the curve there. Finally, you're going to determine the z-score for 60%. So you have to realize that 60% gives you a p-value equal to 0.6000 in the body. So look in the body column. The closest p-value you can find to 6000 is 0.5987, and this gives you a z-score equal to 0.25. From the picture, you need to realize, though, that the z-score that we want is actually negative 0.25. Remember, only your picture can tell you if it's positive or negative. It's negative if it's to the left of the middle. So use your equation to find x. Remember to put in negative 0.25 for your z-score, and you get an x value of 67.5. So a score of at least 67.5 is necessary to be in the top 60% of this distribution.